Good morning viewers, I am Suman Rawat from Civil Engineering Department. Today's topic is groundwater. When there is a precipitation, whether it is in the form of rain or in the form of snow, some amount of water evaporates back to the atmosphere. Some amount of water may flow through the slope and ultimately form stream or small ravines. Some amount of water is absorbed by the root of the plants and a very few amount of water actually seep down. This downward journey of water continue unless it will reach to the zone where all the pores and openings are filled by the water. This zone of saturation where all the pores, spaces, cracks are filled by the water is groundwater or groundwater table. This occurs in the zone of saturation beneath the soil surface. This is the water which is filled in between the pore space and between the grains of sediment enclosed in the sedimentary rocks and filling cracks and crevices in all types of rock. The main source of groundwater is rain and snow that falls to the ground, a portion of which percolates down into the ground to become the groundwater. Now there are two terms which are important to understand the groundwater movement, that is the infiltration. Infiltration is actually the downward movement of the water into the soil under the influence of the gravity, while the percolation is the movement of the water under the zone of saturation. Here again I am repeating, the zone of saturation is the place where all the pores, openings and cracks are filled by the water. The main source of groundwater is the meteoric water or the normal rain, we can say. By this rain, the water may percolate down under the influence of the gravity, which will ultimately reach to the groundwater table. But the another source of groundwater may be the connate water. This water that is present in the rock right from the time of their deposition, especially when we are talking about the sedimentary rock, where most of the rocks are deposited under the sea. So the amount of water which is present in between the pore spaces in the sedimentary rocks, this may term as the connate water. Javelin water, it is also called the magmatic water. It is the water which is formed in the crevices or in cracks or pores of rock by the condensation of the steam which may emerge after the volcanic eruption. Most of the students may get confused when a question comes like what are the sources of water. They may write that the river, pond, lake or the ocean or the ice caps are the sources of groundwater, but the source of groundwater is the meteoric water, connate water and javelin water. River, pond, lake, ocean or the ice caps, these are the reserves or the reservoir for the water, not the source of groundwater. Now when we go deep inside the earth, the first zone is the zone of aeration. In this zone, the cracks, pores or opening are filled by the air only. After this, there may be the soil water zone. In this zone, there may be a thin film of water inside the grains, while in the zone of saturation, all the cracks, pores, opening, these may be filled by the water. This zone of saturation or the upper layer of zone of saturation may term as the groundwater table. Here it is also saying that there is a zone of aeration where the cracks and opening are filled by the air. This is zone of saturation, where all the cracks, openings are filled by the water. In between this zone of aeration and zone of saturation, there may be the capillary zones or the capillary fringes, where the water moves against the gravity. Here the upward movement of water may continue, but this zone is of limited importance because this is a very thin zone. Again, the saturation zones, where all openings are filled by the water. Vadose zone is subsurface zone in which the rock openings are generally unsaturated and filled partially by the air and partially by the water. Capillary fringes, we have discussed about the capillary fringes. This is just above the zone of saturation. This is the small thin layer of the capillary fringes. Sometimes we may get confused between the water table and the river. Generally, the water flow in the down the gradient under the influence of the gravity. Whenever a water table is intersected by some cracks or some pores or some fractures or the faults, this may emerge in the form of groundwater or it may come in the form of spring. Now we will discuss about the movement of the groundwater. Groundwater movement is very slow because this moves under the response of the water pressure. Yes, definitely under the zone of saturation, the groundwater move under the pressure difference. The water within the upper part of zone of saturation tend to move downward following the slope of the water table. Here we can understand this is zone of saturation and here the water is moving under the slope. The groundwater movement is controlled by the two basic property of the rock. These are the porosity and permeability. Porosity is the volume of the pore spaces relative to the total volume of the rocks or the total volume of the sediment or the soil. There may be two types of porosity. Primary porosity, that is the pore spaces in the initial void spaces present, which is also termed as the intergranular space when the rock was formed. Here also I am taking the example of the sedimentary rock. In sedimentary rock, the pore spaces between the two grains, this may contribute for the primary porosity. Secondary porosity may develop later. It may be the result of some fractures, some cracks or the dissolution gravity. It may affected by the degree of shortening and the cementation in the rock. Here we have three examples of sedimentary rock. One sedimentary rock which is well sorted. Sorting means this is the grain size arrangement in the sedimentary rock. It is a picture of the porous gravel where we can see the lots of pore spaces are there and all these pore spaces are filled by the water. So this type of sedimentary rock will have the very high porosity. If I will compare this sedimentary rock with the poorly sorted rock, where the pore spaces are already filled by the some small grains, some cementing material is there, some clay, fine grained sediment is there. So in this type of poorly sorted rock, the porosity will reduce. It is a very well sorted clay or the sills. Here the porosity will be low because the porosity is the percentage of void present in the rock. So in this rock we cannot see any void, so definitely there will be the less porosity. Now porosity is the total void spaces in the rock. Normally, different type of material or different type of rocks may have the different porosity till which is the unsalted glacier deposits. This may have the porosity up to 10%, while the sandstone which have the very high pores or the poorly cemented sandstone may have the high porosity. The clay is having the very high porosity because of the lots of intergranular space between them. Effective porosity is the ratio of void spaces through which water can move. We can see here this ability of pores to pass water from the one pore to the another pore, or which will allow the easy flow of the water. This is called as the permeability. So the porosity is the total percentage of voids which are present in the rock, while the permeability is the capability of rock to allow the passage of fluid. This permeability is dependent on the size of the pore spaces and to what degree of pore spaces are interconnected. The interconnection of the pore spaces is the prime factor over here. If a rock is highly porous but these pores are not interconnected, then this rock cannot be the permeable. Grain shape, size, packing of the grain and cementation affect the permeability. Specific VL, this is the quantity of water that a unit volume of rock can hold. The grain size has a definite effect on the specific VLs. Small grain have the larger surface area, which means more surface tension and a lower specific yield than the coarse grain sediment. So it means to say that a clay will have the less specific yield compared to the conglomerate or the coarse grain sedimentary rocks. Now, water bearing qualities of rock. So as we already discussed, the porosity and permeability is the basic quality of rock which is necessary to become a aquifer. Aquifer is a water-bearing porous soil or rock strata that yield significant amount of water which can be tapped effectively. Example of good aquifers are the sandstone, conglomerate, well-jointed limestone. But the condition over here that if the pores are present or the resolution cavities are present in the limestone, this must be interconnected. Bodies of sandstone in gravels, some fragmental or the fractured volcanic rock such as the columnar joints or the vesicular basalt may also become a good aquifer. This will depend upon their total porosity and interconnection of voids. There are some other terms related to the aquifer, that is the aquicludes. These are the water bearing horizon that may be porous enough to hold good quantity of water, but being effective impermeable, they do not allow easy and quick flow through it. Example is shale, slate and clay. Shale and clay, this is a very fine grained sedimentary rock which is having the high porosity but having the very less effective permeability because their pore size is so small that the water can enter over there. When we tap these rocks, this does not allow the easy flow of the water. Aquifers, these are the absolutely impermeable formation through which there is no possibility of storage of the water or the movement of the water. That means the porosity and permeability is very less. Example is compact interlocking granites, quartzite, silt, mudstone or even sandstone when it is well cemented. Sometime we may use a term that is aquitard. It is the less common term used to end aquifuse that has become locally leaky due to the development of joints and cracks. If a aquifuse which is impermeable, not porous, but there is a little bit permeability or the porosity because of the cracks and joints, this may term as the aquitards. Now types of aquifers. Mainly there are two types of aquifer. One is unconfined aquifer, another is the confined aquifer. A confined aquifer is a partially filled aquifer exposed to the land surface and marked by the rising and falling water table. This rising and falling of water table is directly related to the weather condition. During the rainy season, the groundwater surface, this water surface may come up, so there may be the rise in the groundwater table. And during the summer time, when there is the continuous discharge of water without recharge, then this groundwater table may go below. The large amount of waterfall which is present in the Maharashtra are because of this unconfined aquifer. The water table within these unconfined aquifer may rise up, which may come out in the form of spring or the waterfall during the monsoon time. Wherever as there is a continuous withdrawal of the water, then this water table may goes down and this waterfall may die out. Confined aquifers. These aquifers are also known as the artesian aquifer. This aquifer is completely filled with the pressurized water and separate from the land surface by the relatively impermeable bed such as the sail. This is the example of the confined aquifer, where this aquifer is bounded from the below as well as from the above by some impervious material. So whenever we will tap this aquifer, the water may come out in the form of a fountain or with a very high pressure. Now question arises from where this confined aquifer may recharge. What is the recharge area? Then this confined aquifer may get water from the river which is flowing next to this confined aquifer, because from the above it is bounded by the impervious layer, from the below also impervious layer. So this confined aquifer may get water from the river which is flowing next to this aquifer, or this aquifer may get water from the ground surface only. To become a confined aquifer as a artesian aquifer, there are the three conditions which is necessary. First is there must be some recharge area. This is the recharge area. Unless this porous or the aquifer is exposed to the ground surface, this may not recharge. So there it must be exposed into the surface. Second, there should be a suitable geological structure. Here we can see rocks are not horizontal, but these are forming a half syncline type of structure. So whenever the precipitation is there, then huge amount of water will actually move downward from both the sides. So this may get recharged. Third, if it is a syncline type of structure, then there are the chances of leakage or chances of the extension crack over there. So absence of leakage is another important condition for the aquifer, because here the water is under the very high pressure, and if it may have some cracks, then a huge amount of water may seep down. Another example of the artesian aquifer, impervious rock, and this is a aquifer or the porous and permeable rock, but this porous and permeable rock is getting water from this lake or this river, or this may also get recharged during the monsoon time. So again, the three conditions which is necessary is first is the suitable recharge area, second is the suitable geological structure, a syncline type of structure, and third, absence of any leakage is the primary condition for a artesian aquifer. Sometimes a lens or the non-permeable material will be found within the more permeable material. The water percolating through the unsaturated zone will be intercepted by this layer and will accumulate on the top of line. This water is known as the first aquifer. The top body of this aquifer, of the top water bearing body of this aquifer is separated by some impervious material. Whenever there is a rainfall, the downward movement of water will continue unless it will reach to a regional groundwater table. But when we have some impervious layer within this soil zone, then this water or the meteoric water will saturate this much amount of sediment only. So in this case, we may get the groundwater table at the shallower depth. But this type of groundwater tables are not the reliable source for the water because it is not connected with the regional water table. Very soon it will be exhausted. So it is known as the isolated type of water table which is formed by this impervious layer. In this particular diagram, we can see the confined aquifer which is separated by the impervious layer from the bottom and the top. This is the unconfined aquifer, confined aquifer and purge water table. Now about the fluctuation in the unconfined aquifer. In a unconfined aquifer, when groundwater is pumped from a well, a depression may create in the immediate vicinity of the well. This depression will be created when there will be the continuous withdrawal of the water without any recharge. This was the initial water table. We can see here this is the initial water table, but by the continuous withdrawal of the water, this water table may get shrink at the immediate vicinity of this well. Of course, this will be fulfilled after some time. What time it will take, this will depend upon the porosity and permeability of rock. Such type of depression or such type of inverted cone-like structure which is formed in the aquifer is known as cone of depression. Again, this picture shows this was the initial water table and now this is the cone which is formed by the continuous withdrawal of the water without any recharge. Now, there are some terminology in this cone of depression. First is the static water table. It was the static water table. This H0 represents the static water table. Now, this pumping water table H, this was the depression which was created due to the withdrawal of the water. This is H. Drawdown is the total amount of water between the static water table and the water withdrawal after the pumping. Well yield is the volume of water pumped per unit time and specific capacity is the yield per unit drawdown. The shape of this depression is largely depend upon the type of rock and their porosity and permeability. We can give one example. If a coarse grain, well sorted rock is here, then this curve will be more gentle, while the area of influence, this is the area of influence from where this curves begin to draw. This area of influence will be more, but this curve will be less pronounced. While in case of very fine grained sedimentary rocks where the pores are not nicely interconnected, this curve will become much more deeper, but this area of influence will be less. Because in the coarse grained sedimentary rock, because of their large intergranular space, water will quickly fulfill this depression, while in case of fine grained sedimentary rock, it will take much more time water to pass through the another area to fulfill this low pressure area. After some day or after some time, this cone will reestablish, or it will become parallel to the static water table or the initial water table. How much time it will take, this will depend upon the porosity and permeability of the water. Here we can say this will be the actual shape of the cone of depression. This is in the paper, but when we think about the 3D, it will become a circular shape, cone of depression. Now we can use effectively this cone of depression. Sometime when we are dealing with the contaminated water or the contaminated plumes in the groundwater, which may enter into the groundwater system by some wastewater treatment plant, or some leachate may enter into the groundwater, a well can be placed near the contaminated water. Now we can withdraw this contaminated water. We have to calculate how much time or how much pump will be required to withdraw this contaminated water from the ground. The another use of cone of depression is that if a river is flowing in the nearby area and it is highly contaminated by the physical and the chemical contaminants, then instead of taking direct water from the river, we can take water from the well. Because when we withdraw the water from the well, a low pressure area may create at the immediate vicinity of the well. So the water which is near the river, which is over the river, or which the amount of water which is saturated under the river may seep down, or it will percolate towards the well. So whenever this water will percolate, so in this journey it will pass through the huge amount of rocks or the sediment. So the natural purification may take place. This is very effective to eliminate the physical as well as the chemical contamination from the water. Again, this is a cone of depression, and this arrow show a low pressure area may create over here. If I will make a cross section of this cone into this may be an inverted cone say, but if I will visualize it in the 3D, it will be like the circular path. Now springs, a place where the water flow naturally from the rock into the land surface. Some spring discharge when the water table intersect the land surface, but they also occur where the water flow out from a caverns or along the fractures, faults, or the rock contacts which come into the surface. These are the few examples of the spring. We can see here there is one cave which is the rocks, possibly maybe the limestone. So because some caves are there, lots of pores are there, the huge amount of water may actually seep down. Now there will be the percolation of water under the influence of the gravity. When it will meet to the surface, this may come out in the form of spring. This is the example when the rock, where the less pores are there, or it may be igneous rock. This may be the case of the Maharashtra, where the basalt is exposed, which is jointed. Lots of columnar joints are there. More than 6 set of joints are there. Now the water may seep along these joints. If these joints are interconnected, this may serve as a good aquifer. Now from this aquifer, water may come out, and this may become a stream. There is another example where there is a water bearing horizon which is brought upward because of some faulting. So if I will expand this fault, this may move like this and the water may come out from this fault. Now there may be two types of stream. One is the gaining stream or the effluent stream, a stream that receives the water from the zone of saturation. This is called as the gaining stream. This is common in the humid region. This is the example of the gaining stream. This stream is fed by the groundwater itself. If a stream is flowing in a particular area, it doesn't mean that this may be the table of groundwater. This is not always true. Only in the case of the effluent stream or the gaining stream, it may get water from the groundwater, and in this case the groundwater may be much higher than the stream level. Another type of stream is losing stream or the effluent stream. This is the situation where the groundwater table is much below the stream. So by this stream, a huge amount of water may actually infiltrate, or the downward movement of the water may continue unless it will reach to the zone of saturation. So this type of stream is losing stream, and this may dry out after some time. This may flourish only during the monsoon time, while this gaining stream, or which is fed by the groundwater, it may be a perennial stream. We may get the water throughout the year over this stream. Now what may be the effect of the groundwater movement? This actually comes in the physical geology, where we are studying about the geological work of wind, water, glacier and the groundwater also. The most interesting feature which is formed by the groundwater movements are the caves. These are the naturally formed underground chambers. Most of the caves are developed when the slightly acidic water dissolves limestone along the joints and bedding planes, opening up caverns systems as a calcite is carried away in the solution. When we are talking about the slightly acidic groundwater, whenever there is a precipitation in the form of rain, it is slightly acidic because the CO2 is already present in our atmosphere. So a huge amount of CO2 may dissolve into the water, which may make the water little bit acidic. That means the pH of this water may goes up to the 6.5. Most of the caves are formed by the groundwater circulating below the water table. This is the common reaction H2O plus CO2, which is already present in our atmosphere. When it reacts with the limestone rock, that is the calcium carbonate, it may break down into the Ca plus ions, that is calcium plus ion plus bicarbonic ions. When this bicarbonic acid or the water which we are thinking of, this may be H2O, but actually this is the bicarbonic acid, when it may seep down again from the ceiling of the caves, then it may again precipitate calcium plus ion. This reaction is the development of the caves, and when we will go from the bicarbonic ion plus calcium ion, this may be the again precipitation of calcium carbonate. We can understand nicely over here. The stalactites and stalagmites are the typical features which may be formed by the groundwater action. Stalactites are the ice-like pendants of the dripstone hanging from the cave ceiling, generally cylinder, and are commonly aligned along a crack in the ceiling which act as a conduits for the groundwater. Stalactites, these are the stalactites. These are the stalactites and these are the stalagmites. These are formed by the dripping of the water drop by drop. Whenever there will be the drip of the one water of drop which is having the calcium ion dissolved in it, when a water drop which is full of calcium ion will hang from the ceiling of the caves, some amount of calcium may precipitate over here. As this water drop will fall down into the ground, another some amount of calcium may precipitate over here. So we will get stalactites and stalagmites. Sometimes these stalactites and stalagmites may fuse together. This may form the column. This is the very common feature in all the natural caves. Natural caves are the caves which may develop in the limestone terrain only. All the other caves which we are seeing in the Maharashtra region, these all are the man-made caves. This type of movement is responsible for formation all the siblings in the India. And we can see if the continuous movement of water will be there, the height of this column or the height of this natural sibling may increase day by day. This is the another topography which may develop by the groundwater action of. This is known as the karst topography, where we can get the numerous holes in depression. Even sometime intermittent stream is the stream which may frequently appear and disappear while it is moving to the down reaches. Thank you.